it turns out, if you are careful, you can float fresh water on salt water and you can float oil on fresh water. At University of Washington, we had a great big tall cylinder and we had 5 different liquids that were floating on each other, each one a different color, and we were careful not to bump it, and it stayed that way for months. Now, if I have 5 objects and the density of each of those objects is given, and I carefully and slowly lower those objects into the cylinder and let go, where are they going to end up? Talk to Nimrod. Where are those 5 objects going to end up? Okay, this is not hard. A has a density less than oil, so it's going to float in oil. B has a density greater than that of oil, so it's going to sink in oil. But its density is less than that of water, so it's going to float on water. C has a density that's greater than water but less than salt water. It's going to sink in the fresh water, float on the salt water. D and E both have densities that are greater than that of salt water, so they end up at the bottom. Now, the point I want to make is that things either sink to the bottom or float at the top. They don't end up here. The only way they can end up here is if they have exactly the same density as the liquid, and that's hard to engineer. If something has exactly the density of salt water, I could put it anywhere I want and it would stay because it acts like salt water. But again, that's hard to engineer. In real life, things are either at the top of the lake or the bottom of the lake. But what about Jaws, Greg? What about na-na, 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 na-na? You remember that movie? Oh, you're too young. Scariest movie ever made, and it came out while I was living on Guam, going into the ocean every day. When we were out there snorkeling, all my friends had to do was just every now and again to just na-na, 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 na-na. That was when the shark was coming. And the scariest part of that movie by far was when the sheriff goes down at night with a flashlight, a waterproof flashlight, and he's looking around for the body, but he doesn't find the body, he just finds because it's been bit. And he turns around, no, there's the body. And it's not at the bottom, it's not at the top, it's right there in front of him, kind of floating halfway. Did Hollywood get it wrong? Sometimes they do. But in this case, I think they didn't. In this case, they were using the fact that in a real body of water, there is a temperature gradient. You've experienced this if you've dived into a pond off of a dock. You know that the first 1.5 feet is really warm. The sun has warmed it up. And then it's like you go through this invisible barrier, this invisible boundary, and suddenly it's very cold. And these temperature differences, these boundaries, set up essentially layers of different density. And that body could be floating on one layer and sunk in another layer, like that block right there. Now in this class we're going to ignore the temperature gradient, the temperature difference in our liquids, and just always assume that it's all the same temperature. Okay, I just didn't want you to watch movies and say, oh, you know, they got the physics wrong. They sometimes do. You know, Lois Lane falling and Superman scoops her up. Should have been so much better if she just hit the concrete. He is changing her momentum so drastically, she's just mush. So some of the movies are wrong. Okay. Now, that ship. You understand Archimedes' principle. We just talked about it. That a sinker or a floater? It's made out of steel. A sinker or a floater? Yeah, Lloyd's of London would like to classify that as a floater, and that's why they insure it. But our definition suggests that it should be a sinker. So let me give you an operational definition for sinking and floating. You take a giant, the giant grabs the ship, the giant drags it down to the bottom of the ocean, and the giant turns it over and over and over until all the air bubbles come out. Then the giant lets go of it. If it goes up, it's a floater. If it stays down, it's a sinker. And with that operational definition, that's a sinker. Its density is greater than that of the water. Okay? On the internet, they had some pictures of a boat that came up against a bridge, and someone forgot to raise the bridge, and so it just kind of crashed up next to the bridge and went under. But this is a good boat. He just came up the other side. That's a floater. Yeah, keeps on coming up.